There are two objects being observed in this picture, the boy as object number 1 and the girl as object number 2. It can be seen that the boy is running forcefully to the right direction and is being blocked by the girl, who is exerting a motion force to his opposite direction so that the boy would be halted. Hereby, as they are moving in opposite directions, this results in two opposing accelerations. Each of the object possesses contact forces, which includes normal force and friction force, as well as field force, which is gravitational force, as seen through this free body diagram. Newton's first law, also known as the law of inertia, states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless it is acted upon by a force. It can be observed that this picture demonstrates the law of inertia at work. In this case, the unbalanced force is the difference in weight of each individual. The girl possesses greater inertia as she has greater mass. Furthermore, the object will not move unless an unbalanced force, or the weight, acts upon it. Newton's second law is a quantitative description of the changes that a force can produce on the motion of a body. It states that the time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. The momentum of a body is equal to the product of its mass and its velocity. Running, or in this case running whilst giving a piggyback ride, could be a good example of the second law of motion at work. The person riding on the guy in the yellow shirt acts as the mass, whilst the body, primarily the legs of the person in yellow, is the force, as they keep on running. The weight of the person given the piggyback ride definitely slows down the acceleration of the person giving said piggyback ride. Essentially, the speed of the person running is determined by its weight as well as the extra weight it is carrying. By analyzing this picture, we can see that this event demonstrates Newton's second law of motion, as it depicts the relationship between the mass of the object, its acceleration, as well as the force applied, thus showcasing F equals m times a. This concept is also affected by several other factors, including the frictional force from the stage, as well as the other person pushing the guy in yellow backwards, thus impacting his force and acceleration. Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. Also known as the law of action and reaction, this law simply states that every action has an equal opposite reaction. In a game of tug-of-war, the two opposing forces create an action-reaction system. As they apply roughly the same amount of magnitude and tugs in opposite direction forces to the ground, this creates friction, thus producing zero acceleration as the system's net force would equal to zero. However, the direction as to which the rope favors depends on the forces exerted by the two teams. When the forces are unbalanced, the system will accelerate in the direction of the net force. Potential energy is the energy that is stored or conserved in an object or substance. In the case of this image, the person being lifted by the swing possesses potential energy when positioned at the highest point because of the height in which they are positioned. As the swing falls back down, the potential energy will then be transformed into kinetic energy as it will be correlated with the speed or its motion. The two persons shown in this picture can be predicted and analyzed to have different amounts of potential energy, as the mass differences directly affects the amount of potential energy possessed by an object. Predicted that the girl has a mass of 30 kilograms with a gravitational acceleration of 9.8 meters per second square and lifted off in a height of 0.4 meters, following the formula potential energy, which is mass times gravitational acceleration times height, then the girl's potential energy would be 117.6 joules. With the same gravitational acceleration and height as the boy is predicted to have a mass of 24 kilograms, then his potential energy would be 94.08 joules. Kinetic energy is the energy that an object possesses due to its motion. In the case of this image, the person is the object and is running, which means that the person possesses kinetic energy. Kinetic energy follows the formula of Ke equals half times mass times velocity squared, which means it is directly affected by two dependent variables, which is the object's mass as well as its velocity. These two variables may be manipulated or changed based on the objects observed. Therefore, two people with different masses, even if they are moving at the same velocity, will possess a different amount of kinetic energy. Predicted that the boy has a mass of 20 kilograms with a velocity of 2 meters per second, following the formula of this kinetic energy, then the boy would have a kinetic energy amounting to 40 joules. The law of conservation of energy states that energy can neither be created nor destroyed, only converted from one form of energy to another. In the case of football, when you pull your arm back to throw the football has gravitational potential energy. As the ball is thrown, the potential energy will be transformed into kinetic energy and heat energy. The kinetic energy now possessed by the ball is useful for the ball as it helps the football travel to its destination. However, the heat energy also possessed by the ball is wasteful energy as it does not help the ball travel to its destination. Therefore, it can be seen that the event within the picture correlates to the aforementioned law. Predicted that the mass of the ball is 0.4 kilograms with a gravitational acceleration of 10 meters per second square and a height of 1.6 meters, its potential energy at point A, right before it is thrown, is 6.4 joules and a kinetic energy of 0 joules. As mechanical energy is the sum of the potential energy and kinetic energy, then the mechanical energy at point A is 6.4 joules. At point B, the object is in motion, which means the potential energy has been transformed to kinetic energy. Thus, its potential energy is now 0 joules. Following the law of conservation of energy, the mechanical energy at point B will be equal to that of point A, which is 6.4 joules. This means that the kinetic energy at point B is now 6.4 joules with a velocity of 2.83 meters per second. As we all have come to learn, change is evidently inevitable. Heretofore, it is vital that visionary leaders learn to adapt and habituate themselves in this ever-changing world. Transformation can be seen in our day-to-day activities, predominantly through physics, such as the transformation of energy. The field of physics continues to educate us on multifarious principles and laws to control or enforce rules in order for humans to understand how the world operates. The rules of physics are simply our interpretation, as humans, of how the world around us works. Therefore, with this knowledge, people would be able to more objectively interpret the changes that exist in their everyday lives.